So today we're solving higher order ODEs that are homogeneous and with constant coefficients. If you recall, homogeneous means the function on the right hand side 0, and with higher order you just have an nth derivative. This is in general. A constant we call a sub n times the nth derivative, plus a constant we call a sub n minus 1 times the n minus first derivative, and we just keep going until we run out of derivatives in the function. So we'd have a constant a sub 1 times y prime plus a sub 0 times y equals 0. And if you remember, we solved these sorts of problems for second order by assuming y equals e to the RT. So our first derivatives are e to the RT, y double prime is r squared e to the RT, and the third derivatives are r cubed e to the RT. The fourth derivative would be r to the fourth e to the RT, and we keep going till we got to the nth derivative, and that'd be r to the nth power e to the RT. So when we substitute all these derivatives in the function into our differential equation, we would end up with a characteristic equation, just like we did with second order. So we'd have the number a sub n times r to the nth power all the way down until we got to the number a sub 1 times r, and plus a sub 0 equals 0. So let's work through an example to see how this applies. So this is a third order differential equation, because that's the highest power is the third derivative. So we end up with r cubed e to the RT minus r e to the RT. When we factor out e to the RT, we're left with r cubed minus r. And we know this expression's never 0, just like we did with second order. So we get the characteristic equation r cubed minus r equals 0. If you factor out the r, you get r times r squared minus 1. You would then factor that, again, because that's the difference of squares. So here our roots are r equals 0, r equals 1, and r equals negative 1. And we could number those, r sub 1, r sub 2, and r sub 3. So what are the three solutions that we know? We can come over here. So for this r, that'd be either the 0t, that would be 1. Our second solution, that would be e to the t. And our third solution, e to the minus t. So we have three solutions. They happen to be linearly independent. We could check that out if we wanted to with a 3x3 Röntgen. So our general solution would be y equals a constant times 1, that's just 1, plus a constant c sub 2 times e to the t, plus a constant c sub 3 e to the minus t. And there we have it. That's the solution to this third order homogeneous differential equation.